I was just about to search for a new toilet brush to replace this one that's busted. And then I thought, hey, what's actually wrong with this? It's only just that the thread on this little plastic insert has been destroyed. Instead of it ordering a whole new brush, one that's already mounted to the wall, this is just the inside part, and a new cap, I can just design and 3D print them. So that's what I'm going to try and do here. I'm going to design a new handle, obviously pretty simple design, measure, design a new cap. The main thing I have to do is get the thread right, but if I can get the thread right, fit to this brush, I'm going to print it in some matte black PLA, save myself $50. So let's jump into SolidWorks and I'll show you how I'm going to do it. This is should be a very beginner friendly demonstration of how I can use SolidWorks to recreate something that exists, improve it, export, send to a 3D printer. I'm starting with a new part, fresh file, and I'll do this in multi-body. So I'm going to do 2 bodies in one file. First part I'm going to do is this round disc, the cover plate. And there's a few ways I could do it, but I'm going to simply do a extrude. So I'm going to start with a circle on the top plane. And the key thing I'm measuring with this is the inside shape, because I need to fit it over the cap of this on my desk, plus the metal part that goes around the outside. So diameter I can see is about 90.2 millimeters. I'm going to make it a tiny bit bigger because I think the fit is a little bit tight. I'm going to go to 90.6. And then what I'm going to do is measure the thickness of that wall, which I can see is about 0.8 of a millimeter. But I don't need to sketch that because what I can do is a thin feature extrude. With this thin feature, I'm going to increase that thickness slightly, put it up to 1 millimeter, and then measure the height. Here I can see 8.5. So my distance is going to be 8.5 millimeters. Now I just have to make sure the thin feature is on the outside of the sketch. You see when I press this button here, it'll flip. I want to make sure I'm the outside. That's okay. Press the tick. And now on the top, it does have a slight curve to it. So I can do the same thing. I'm going to cheat a little bit. First, I'm going to convert this edge. So I've selected convert entities to get that outside edge. I'm going to extrude. This time I'm just doing a solid extrude, but I'll go 1 millimeter straight up. And then to get that little curve on the top, ever so slight, I'm going to use the dome tool. And I select this face. I'm just going to put in 0.5 millimeter or maybe 1 millimeter for the dome. You can see it's adding this slight curve to the top. Now you can tick elliptical dome and that's going to curve it on the edges, but we don't want to do that. We'll add a fillet afterwards. Okay, so it's got a slight curve on the top, and then we need to make the hole through the middle. So I'm going to get the calipers, measure the diameter of that hole, even from the top side here, 10 millimeters. So start a sketch on the underside, make that hole. I'm going to make it a tiny bit bigger, 10.2, and that one is going to be extruded cut through all. And then to finish it off, I'm just going to put a little radius on the outside. You can do that one by eye, 0.5, maybe 1 millimeter. And if we have a look at a section view, we'll work out if we need anything on the inside. I don't think so. That'll be okay. Now, when we 3D print this, we'll probably print it this face up, which means this side will be the messy side, the underneath, where we remove support material. I suspect it'll be fine. But if we have issues and it's too thin, then we can always just come back to the SolidWorks file and increase the thickness. All right, first part done. I'm going to save the file, or let brush holder replacement. All right, that first one's done. Very simple feature. The next one, outside of this shape, even easier. Not much to it at all. Now we're going to do multi-body, which means I'm going to start on the top plane. I'm going to sketch the handle shape. The outer diameter of this is 16. I'm going to make it a little bit bigger because we're 3D printing. Doesn't really matter. I find the original one a bit small, a bit skinny. And then the length of this part is a reasonable size. It's 130 millimeters. What I'm going to do is select extrude. I'm going to make my distance 130. I'm going to see if I can start it from this top face, which I can. And what that means is there's got a bit of a curve to the bottom face. So the bottom is going to exactly match what we can see here, but the top is straight. I'm going to uncheck merge result, and it's going to keep it as a separate part. We see the top is flat because I can do a sketch on that face. Now, if I want that top to have a little bit of a curve to it as well, I could do the same thing and add a dome. But for this part, this is actually going to be the face that's going on our printer. So I don't really want to add anything to it except for a fillet, which will be the same size as the other one. Now, again, if I find issues with the fillet in the 3D print that it's not getting nice detail there because it is the top of the part, I might change that to a chamfer later. Now, the important part of the brush holder is the inside of this one. Most of it can remain hollow, but I do need the hole to have an equivalent thread on the inside so it will screw onto this metal piece. So I'm going to hide this body so I can just look at the holder part. And the first thing I'm going to do is measure the opening diameter. So inside, this will give me an idea of the thread size. So that's 9.2. If I try and measure the thread on this, 9.55. If I had reality for this project, I actually don't need the thread to be the perfect size. I just need the plastic in the 3D print to have enough wall space, wall thickness and strength, and be close enough fit so that I can actually screw the metal thread into the plastic. So it's not crucial that it is perfect. In fact, probably the best approach might be to measure the inside thread here on the handle and just make the hole on the inside on the bottom a little bit smaller than that. All right, so I'm going to go on the top plane and I'm going to make it, so it's measuring at 9.2. Let's go to 8 millimeters. Now, in my thinking is that I have a bunch of drill bits downstairs. If I find that the 8 millimeters is too tight, I can always get my drill and drill it to 8.5 or 9. So I'm going to start smaller. If I make it too big to start, I can't add material back on once I've already printed it. And then the depth of this hole, like in this one, it goes all the way through. I don't need to do that. I just need to make sure it's long enough for this brush, this threaded part on the end. And this threaded part is 14 millimeters. So if I do my cut, let's make it, say just 20 millimeters. I'm going to select this face to go from there. Right there is my cut, my hole into my part. If I want to show my lid, I can see the two now, and this is almost ready for 3D printing. Before I do that, I'm just going to have another quick look at the assembly of this, see if there's anything I can improve. So I can see that the lid just sits on the top of that. It's a little bit loose, but I think once the handle comes on, ideally makes it tight. That'll give it a good fit. It's the thread on the bottom that pokes through the hole, so I don't really need to worry about doing anything fancy in the rest of the CAD. The only other thing I could do if I wanted to was add some thread, 3D print. But you might get mixed results doing that. So if I want to measure, try and get accurate, what I can do is measure the pitch of this, which means from one spiral to the next, it's 1.5 millimeters. Let's just have a look at what the inbuilt threads give us. We go metric die. We want to go 9 millimeters, and we do not have a 9 millimeter. 90, not 9. If I try and 12 by 1.5, it's going to give me the pitch that I'm after with start face. Now that has cut some thread for me into this part. If we look at the pitch between these, so I can go from point to point here, that shows 1.5, 4 millimeters. So this may help us thread on to the metal part just by adding some detail in there that, you know, we're not actually cutting away as much material when we're for the first time screwing this onto the metal. I'm going to give it a go. We'll see how that works. All right. So this looks pretty good. Now I'm going to save as a step file. Step is my preference for 3D prints. You can do STLs as well. I just use step because if I'm also exporting for supply files, things to go to suppliers, I'm usually sending a step file then. So it saves me time having two different files. All right, with that saved, we'll come back into the Bambu Studio slicer software and I'll show you how that works. So in the slicer here, all I'm doing is clicking and dragging to import my step file. And what we can see is it comes in as one part, but you can split that into objects. So being a multi-body part file, we can split it, and then I can treat the objects separately, and that's what I want to do here. So the process I'm going through once I've imported it and splitting it is just getting the best orientation for the parts. In this case, it's pretty straightforward. The handle with the thread needs to be at the top. And I'm increasing, I like to work on like the fine quality to get a better finish on the outside of the handle. But I also know I want to have a very strong part, so I've increased the number of walls. And here I'm just doing a preview to see what it would be like to print both parts at the same time. I can see that there's obviously quite a bit of support on the cap part to support that main area. I decided to print them separately so that I can play with the handle while the cap part is being printed. So it's really just a matter of timing. If I was something I was going to print overnight, I'd just print them both together and leave them, grab them in the morning. Now I've added a brim to this one, so it's just going to keep it nice and upright, just reduces the risk of failure for the first print. And once I'm happy with the preview that I see, I can send that across to the printer. Now, I did print that one separately, clear the plate, come back and set the second one up, which is what I'm doing here. Now this one has support material, whereas the handle didn't. So I'm just getting that support material in. I'm making sure that looks okay. I'm not too sure at this point whether it's going to peel away easy or not, but that's something we'll just see when the print comes off the bed. All right, we're here now with our 3D print. This is the one we printed first. You can see the original, same length, similar finish. This does have the seam line right here, but it's pretty hard to see. Just taking the edge off the top. We can see the hole though, quite a bit of difference. Now I've tried quickly. You can see it's not quite going on. So I'm gonna have to open up the hole up a little bit. Now I've got a 8.5mm and a 9mm drill bit here. All I'm gonna do is put that to the drill and just try and take off the first couple of millimeters. Okay, just to open it up. That. Now, I'm not trying to take out the thread. I still want to keep the bulk of the thread there. I just want to make it big enough so that this can start threading on. All right, not perfect, but let's give that one a go. So that was just 8.5mm diameter. I want to see if this will thread on. Okay, and I can feel it starting to engage. Okay. Yeah, if I turn it, what I'm hoping is that this is going to start cutting some of the plastic out. And I'm just going to try and remove this tape before I do put that on. All right, that's done. So I'll just put this on now. I don't want to put it all on the way. I'm not putting it on permanently because I'm still waiting for the next part to print. But I can feel now that that is threading on. One issue is it might not be straight, but I feel pretty good about that that's going to have a nice strong thread. So let's wait for the cover plate now to finish printing, then we'll come back and assemble the final thing and give it a test. And with this, see the white layer there, that's the support PLA. Now that's just the interface layer between the PLA on the outside and the PLA that's being used for the supports as well. Hopefully, we could just peel it out, but sometimes it needs a little bit of force. Oh, quite strong. Okay, now that we've got our cap and our handle, the cap, we know it's going to fit this one. This is the small one. When we put this on the middle outer part, that's where we'll see how well that fits. But now we can put these two together. So I've got the brush here. I'm going to put the cap over the top. And then with this one, where I've just opened up that hole ever so slightly, I can screw that on. And if I can feel the thread gripping, then we're good. I'm just going to thread that down. And I can feel it starting to bite into the plastic. It's quite tight, which is good. That's what I want. I've got 4 walls there, so plenty of thickness of material that's going to pull through and keep it strong. Okay, that's now, it's not loose at all. You can see here, no gap, nice and solid. Let's put it all together and see how it goes. And here we are, final test. Job done. So designing a toilet brush holder or handle is not the most exciting thing in the world, but just being able to repair something and not go out and buy something completely new to replace a functional object in the home, I think that's pretty useful. I've got a growing list of home projects to get to, and it's just a matter of time. So what kind of objects do you have around the house that you think could do with a repair or upgrade via 3D printing? Let me know in the comments. I'll be keen to see if anything on your list lines up with what I've got to do here. Thanks for watching. See you in the next one.